Hi everyone. In this video, we will compare and contrast the verbs evaluate and solve. And we'll do this on some more challenging algebraic manipulations. So here you can see we have the function f of x is equal to x over x minus 7. We're asked to evaluate f of 1 over t. Remember that when you evaluate, you're given an input and you substitute that in wherever you see an independent variable in your original function. So I'm going to evaluate f of 1 over t. That means that I need to substitute 1 over t wherever I see an x. In this case, I've got 1 over t over 1 over t subtract 7. Now, these two terms in the denominator we need to combine, but we can't combine them until we have a common denominator. And so I'm going to take 7 and I'm going to multiply it by t over t. Remember, 7 is the same as 7 over 1. I'm multiplying by t over t, which is just a fancy way of multiplying by 1. So I'm not going to change the value, but it's going to look different. We now have 1 over t over 1 over t subtract 7t over t. These two terms can now be combined. Simplifying, we have 1 over t over 1 minus 7t over t. Recall that if I divide by a fraction, that is the same as multiplying by its reciprocal. So dividing by the fraction 1 minus 7t divided by t is the same as multiplying by t over 1 minus 7t. Now, what you have is 1 times t, there's a factor times 1 factor, divided by t times the quantity 1 minus 7t. So we have t over t reducing to 1, and that leaves us with 1 over 1 minus 7t. That's the cleaned up, simplified version of f of 1 over t when f of x is x over x minus 7. Now we'll add a layer, and we'll do that by evaluating f of 4 over t plus 7. So again, I'm going to substitute in. Evaluate means you put something in. 4 over t plus 7 wherever I see my independent variable x. So in this case, we'll get 4 over t plus 7 over 4 over t plus 7 plus 7. I'm sorry, minus 7. That's better. That minus 7 is coming from here. So there's our input, and then subtract 7. Now, again, these two terms cannot be combined until they have a common denominator, so I'll multiply 7 over 1 by t plus 7 over itself, which is just 1, remember. This gives me 4 over t plus 7 over 4 minus 7 times the quantity t plus 7 over t plus 7. Once again, dividing by this fraction is the same as multiplying by the quantity t plus 7. Notice I'm going to wrap it in a pair of parentheses. Over 4 subtract 7 times the quantity t plus 7. Now, t plus 7, that factor shows up in both our numerator and in our denominator, and so we can reduce. T plus 7 over t plus 7 reduces to 1. I'm also going to expand by distributing this negative 7. And now we have this gives us 4 over 4 minus 7t minus 49. This is equal to 4 over negative 7t minus 45, which is the same as if you factor a negative out of your denominator, you can put that off to the side of the fraction. Negative 4 over, and then in our denominator we've got the quantity 7t plus 45. Again, take a moment and consider how those are the same. Now, we've worked with the verb evaluate. The verb solve, recall, means that we're given an output, and we're asked to find or solve for the input. So we know that the output, or f of x, often we call this y, is equal to 3. We want to solve for the x values which make that true. So we'll say 3 is equal to x over x minus 7. If we multiply both sides by the quantity x minus 7, those two reduce to 1. We'll distribute our 3. We get 3x minus 21 is equal to x. We can add 21 to both sides, subtract x from both sides, and now we have 2x is equal to 21. Divide both sides by 2, and we get x is equal to 21 halves. 21 halves, of course, is 10.5, or 10.5, and you could substitute that value back in to check. Same goes for the second example here. F of x is equal to -1. We'll put -1 in for our output. -1 then is equal to x over the quantity x minus 7. Okay. Of course, I just realized I may not have said clearly that we're using this function for these two examples. I should have said that because we use a different function over here. So my apologies for not saying that clearly. To multiply both sides by x minus 7, we get -1 times the quantity x minus 7 is equal to x. Distribute our -1. We get -x plus 7 is equal to x. We can add x to both sides. 2x is 7, divide both sides by 2, and x is 7 halves, or 3.5. Again, you can certainly substitute that value back into f of x up here to check your answer. Last but not least, evaluate f of a. So now we're evaluating, we're going to substitute a. Again, this is a different function than the previous few examples. If we put a in, we get 7 times a over 7a plus a. 7 times a is 7a squared. 7a plus a is 8a. A squared over a reduces to just an a in our numerator, and we are left with 7a over 8. Now our answer in this case has to be left in terms of a.